GATE 2015 Civil Engineering Set 1 question number 42. A square fitting 2 meter into 2 meter is subjected to an inclined point load P as shown in the figure below. The water table is located well below the base of the footing. Considering one-way eccentricity, the net safe load carrying capacity of the footing for a factor of safety of 3.0 is in kilonewton. The following factors may be used. Bearing capacity factors given are NQ 33.3 and gamma 37.16. Safe factors FQS and FYS. F gamma is 1.314. Depth factor F gamma D equals to 1.113. Inclination factors FQI 0.444. F gamma I 0.02. Reference to the relevant NPTEL courses or video has been cited. Now coming to the useful data part, if total load Q is acting on the footing eccentricity, it means that the load of action, or we can say the line of action Q, is not passing through the CG of footing area, then a width and the length of the area should be reduced such that the load will pass through the CG of the reduced area to determine the safe bearing capacity and to increase the factor of safety. So if the load is acting at some eccentricity, the length will be reduced to L dash, that is L minus 2 into eccentricity in y direction, and B dash will be the new direction, which will be B minus 2 into eccentricity in x direction, and the new area will be A dash, that will be B dash into L dash. Here we will be using the another equation that is from Meyerhoff's theory to compute the ultimate bearing capacity, which is C into NC SC DC into IC plus gamma DF into NQ SQ DQ and IQ plus 0.5 B dash gamma into N dash S gamma D gamma and I gamma, where C is the cohesion of the soil and DF is the depth of foundation, B is the width of the foundation, and S, D and I are safe depth and inclination factor for Meyerhoff's theory. NC and NC, NQ and N gamma are Tarzagi's bearing capacity factors, and if in the question the inclination of load acting alpha is given as 0, then the inclination factors will be 1, and if the phi is 0, then NC will be automatically 514, NQ will be M1 and N gamma will be 0. And to compute the ultimate safe load or safe bearing capacity, that will be QNS plus sigma dash, where QNS, which is net safe bearing capacity, will be Q and U by F, where F is factor of safety, and we can also write Q and U, which is net ultimate bearing capacity, will be QU minus sigma dash, where QE is the ultimate bearing capacity. Now if we have to calculate the net safe load, that will be net safe bearing capacity into area, and the safe load will be safe bearing capacity into area. Now coming to the video solution part, here in the question the safe factor are given as SQ and S gamma equals to 1.314 and DQ and D gamma are given as 1.113, IQ is 0.444 and I gamma is 0.002. Terjagi's bearing capacity factors are NQ is 33.33 and N gamma is 37.16. As load is acting eccentrically in one direction, that is the width direction, so we can calculate the new dimension, that will be B dash minus B dash equals to B minus 2 into eccentricity in x direction, so that will be 2 minus 2 into 0.15, that will be 1.7 meter. Now using the Meyerhoff's bearing capacity equation, we can calculate the ultimate bearing capacity, that is Qu is equal to CNC into SC DC IC plus gamma DF NQ into SQ DQ and IQ plus 0.5 B dash into gamma into N gamma into S gamma D gamma and I gamma. In the question the value of C is given as 0, where the unit weight is given as 18 kilonewton per meter cube and the steering angle is 35 degree and the depth of foundation is 1 meter. Now if you put the value in the equation, we will get Q equals to 0 plus gamma is 18 into depth of foundation is 1 meter into NQ is 33.3 and SQ is 1.314 and DQ is 1.113 and IQ is 0.444 and 0.5 into B dash is 1.7 meter into gamma will be 18 and N gamma is 37.16 into the safe factor is S gamma is 1.314 into D gamma is 1.113 into I gamma is 0.002. Now if we solve it, we will get Qu as 405.84 kilonewton per meter square. That is our ultimate bearing capacity. That is ultimate bearing capacity. Now we know net ultimate bearing capacity, that is Q and U, will be QU minus sigma dash, which we can also write as QU minus gamma into df. So QU is 405.84 minus gamma is 18 and depth of foundation is 18 into 1, so it will be 387.84 kilonewton per meter square. Now the net safe bearing capacity, that is QNS, is QNU upon factor of safety, so we can write it as 387.84, and the factor of safety given in the question was 3.0, so it is 3.0. So it will be net sea bearing capacity will be 129.28 kilonewton per meter square. Now net safe load will be QNS into new area. So that will be 129.28 into new area will be 2 into 1.7. So that will be 439.55 kilonewton. So this is our net safe load. The answer should be between 434 to 444 kilonewton, but the answer is coming as 439.554, which is nearer to 440. So this is the right answer. Reference to the relevant NPTEL courses or video has been cited.